Today we'll finish our world and look at how to load it into the game, and then we'll add a camera into it to look around. First thing I'd like to add is a skybox. Right now our sky is just blue, and I like it to be something else. So I've already imported a cube map. Here it is. It's just a cube map from the tutorials project. If you'd like to load your own cube map, it has to be laid out like this. All the images should be in a straight line, and then when you select cube texture in the mode, it gets correctly interpreted as a skybox. So now to add this, we just open our environment, sky, and drag the skybox into the skybox slot. And now we see that here it is. The next thing I'd like to have is some grass. We'll make simple billboard grass, and for this I already have this simple mesh that will put the texture on. Here's our texture. So we open a material, put grass here, and it looks fine from this side, but if we look at it from behind, we'll see that it disappears. It's because of the material culling. It culls the texture on the back side of the mesh. So if we disable this culling, here is our grass. Right now it's just in alpha test mode, but often the grass is animated. For example, it moves in the wind, and to do this we can just open the technique and select grass. And here we see that now it's slightly animated. It moves a bit. To add the grass into the world, we definitely don't want to place it one by one, so we want to paint it. Object, paint, let's put grass here, and allowed materials, let's have only grass. And now, if we paint it, we see that we have some grass objects, but they're very far between. And to control this, we have the collision radius option here. It controls how far away objects should be from each other when painting. So if we make it much less, and then increase the speed at which we paint, we can add much more grass much more quickly. I think it's good enough for now. And now the last thing I'd like to do is to add some trees. For trees, I have this model here. It has two materials. One material is for the bark, and one material is for the leaves. So let's add the bark here. It will be just an opaque material, and here we have it. And for the leaves, let's open its materials and drag leaves here. And we see that leaves are in place. And once again, like with grass, we probably want them to move a bit. And for this, we can select the leaf technique, and they are moving. And here we also have some settings for the material. If you hold the cursor above the image, you can see some instructions on what to do. Here we can add some points at which the branches attach to the tree, and based on this, they will be animated. So let's add a point here and a point here. Here you can also set random bending for the leaves. And here you can have random color for each leaf texture. For example, here I have, let's say, 0.5, and set random color, and you see they changed color a bit. Let's make it more visible. Here we have much more random colors. Once again, we'd like to paint the trees here, and this time we want to change the setting terrain normal align. Right now, all the objects we paint align to the terrain. So you see this grass follows the slope of the hill, but trees generally grow upwards, so we probably don't want to align them, and we set it to 0. We also increase the collision radius for trees, and let's make it so that we only grow trees on relatively flat terrain. And we can add some trees like this. Now that we've finished the world, let's see how we can load it into the game. For this, we'll need to write some code. I have already written it, and I'll just explain it. First thing we need to have is a game world new. This loads a world into our game, but we need to pass it either the world name as a string or the unique identifier. A unique identifier, or a UID, is an identifier that each element of our project has, and it's really convenient since you can rename elements, move them around, but the identifier will stay the same, and so the code won't need to change. And how do we add it? There are two ways. One is to go to our world, right-click, properties, and here is the ID. We copy it, and then paste it here. But if you are using the editor, just drag the element here, and the ID gets copied. And you can also see that it says what kind of asset is here. And to prove the point, let's rename our world into game world, and it automatically renames here. And if we move it around, let's say out of resources. Now it's just game world since it's not in the resources folder. The next two lines check if the world has an environment applied to it, and if it has, then just set this environment to this world. What does it mean to apply an environment? Remember when we were editing the world and we dragged our environment onto it so that it stays even when environment is closed. This also apply this environment to the world, to its settings. So now we can just set it. In the shot, we just add some cleanup, deleting the world. And then in the update function, we add game world update and the coordinates. These updates our world at this place, and we pass the coordinates since the Esenthel engine by default has world streaming enabled. So the areas that are very far from whatever position we set here are not updated. If you'd like to have the whole world loaded at once and updated at once, then you can set the world mode. You can see there are world stream, so this mode streams the world. World full loads the whole world at once, and world manual means you will manually control which areas are loaded and unloaded. Right now we have the world stream mode, so we update it like this. For rendering a world, we have an additional render function. Here we can set different rendering instructions for each rendering stage. For now we have just game world draw. It automatically detects the rendering stage and uses the correct functions, but we'll later see that we can add more stuff to this when we need. And in the main draw function, we just pass this render function to the main renderer. One thing we forgot is, since we have water in our world, we also need to call in update function water.update and then give it a vec2, which is its wave speed move. And now let's run the game and see what happens. And here we can see our skybox, our world, but our camera is currently in the default position and does not move, so you can't really see that much. Let's add the proper camera. For the camera, I have this simple setup, just a namespace for cameras, a camera object, and a create function and an update function. In the create function, we'll set our initial parameters. Let's make a simple spherical camera, which will rotate around 1 point. And for this, we have the camera.setSpherical function. Here we pass it its at position, which is the point it looks at. It's your pitch, roll, and distance from this at point. This is all we need in the create function. And then in the update, we need to begin the update of the camera and then end the update of the camera and set it. Between these update begin and update end, we have all the logic for updating. Let's say we want to only move the camera when the right mouse button is pressed. So for this, we check if mouse button is pressed in this frame. 1 is the index of the right mouse button, 0 is left, 1 is right, and 2 is middle. And if it is, we change the yaw and the pitch of the camera according to the mouse delta. Delta is how much cursor moved in this frame. And after we change everything, we once again set the camera and pass it all our new parameters. In our case, only yaw and pitch changed, but I'd like to pass all the parameters as main camera.add.camera.yaw in case we change any of them as well. And now let's add this camera create in our init function and camera.update in our update function. And now let's run the game. And we can see that we have a camera which rotates around. We see that our water is moving, and if you look really closely, our trees are as well. And here we have set everything up.